This is the screencast for section 5.4, example 7. We're going to find the area in between a curve and an x-axis by using our calculators, using NINT. So we're going to find this area of the region between the curve y equals x cosine of 2x and the x-axis over the interval -3 to 3. Now, as you can see, the graph of y equals x cosine of 2x has some negative area, some area below the x-axis, and some positive. Well, since the graph is asking for just area, or the directions are asking for just area, we want all positive. So if we just put in our calculator the integral from -3 to 3 of our function, we'd get, let's see, well, 0. As each of these little pieces is on the opposite side of the x-axis on either side. So we have like a negative piece that looks like this and a positive piece. Those would cancel out. A positive piece and a negative piece, those would cancel out, etc. So this area is 0. The signed area is 0. The integral is 0. This down here, though, would represent how we would do this on our calculator. All you have to do is take the absolute value of the function. As you can see, the absolute value of x cosine of 2x brings everything above the x-axis and makes it all positive. So if you take the antiderivative now, or integral from -3 to 3 of the absolute value, that's going to get you all positive area. So the area in between this curve and the x-axis isn't 0, it's 5.425, units squared. The Now Try problem number 51 asks us to do the same thing. Use NINT to solve the problem. Find the area of the semi-elliptical region between the x-axis and the graph of y equals square root of 8 minus 2x squared. Well, here's the semi-elliptical area, 8 minus 2x squared, or square root of that. And you may be thinking, well, that's just positive anyway, it's all above the x-axis. And yeah, of course, some of these graphs, when it asks you to find the area, they're not going to have anything below the x-axis, so it doesn't make a difference. But just to be safe, if you're not given the option of graphing, why not throw the absolute value down there and take the integral from -2 to 2, and then now you know for sure that the area of the semi-elliptical region would be 8.886 units squared.